So hi, I'm Andy Warner. I work for HPE. I was part of the SGI acquisition. I'm a distinguished technologist in the Advanced Technologies Group, DCIG. Hewlett Packard Enterprise is a massive company, so I think it's worthwhile knowing whereabouts in the ecosystem we fit. So let me just see here. So I just want to describe the data center infrastructure group is the home for HPC within HPE. And within DCIG itself, the Advanced Technologies Group, the group I work for, we focus on disruptive and emerging technologies. And so this early access HPC program for ARM is one of the projects that the Advanced Technology Group is leading. And unfortunately, there was a slight misunderstanding with the title. I didn't understand when I first proposed topics to talk about. I didn't understand the time constraint today, so I'm not actually going to cover Gen Z, which was suggested by the agenda. But just in case people wonder what that was, it's Gen Z's. You can go to the link on the shown on the page. Gen Z Consortium. It's an open systems interconnect, specifically designed to provide memory semantic access. And it can do that intra-node or inter-node. It's a very powerful system that scales from inside a PCB or inside an SoC all the way to very large systems. So Jim already let slip the internal code name we use for this project. This slide deck just talks about a early access program. The code name for it is Comanche. Some people in the room are familiar with that. I just want everyone in the room to be familiar with that. We may flip between the two. But so the mission for the program, specifically for us, was to accelerate the ecosystem development for ARM, the HPC ecosystem development for ARM, and specifically based on open standards and software. So it wasn't for us to generate a private walled garden killer environment for HPC. It was for us to enable the ARM ecosystem to compete in hand-to-hand combat with other processor families within HPC. I think that's good for business, it's good for the HPC community, and it's good for innovation. So everyone involved with the program believes that. So we set up to do an innovative program where we partner with key collaborators. I'll talk more about that later. The goal was to develop a very robust HPC software stack. We trust the hardware vendors to create a compelling range of SoCs. HPE knows how to glue chips down onto FR4 standing on our head. So building systems out of it wasn't the problem. The Achilles heel was the software. And so we specifically set out to build that software ecosystem and pave the way for large-scale ARM HPC deployments like the one Jim talked about, Vanguard. Pave the way for things like that to be completely credible from both a hardware and a software standpoint. The program started back in February this year, and it's ongoing. So first, just what's the hardware? So we took an approach where we said, let's pick some off-the-shelf run rate HPC-friendly platform that HP is already making. And we picked the Apollo 2000, basically. It's a 2U 4-tray enclosure. So we designed a compute board based around the Cavium Thunder X2. It's a dual socket system. So it's got a total of 16 DDR4 DIMM sockets. We got M.2 SSDs on the motherboard. We support up to 2 3.5-inch drives in the drive bays at the front of the chassis. We have two configurations. You can buy either stacking 4. The densest compute option is just 4 2-socket compute nodes per 2U rack, 2U enclosure. Or you can equip it with GPUs, which takes up sort of the second U, and you can only get 2 of those per enclosure. The GPU we're using for this program is the AMD FirePro 9170. So we also equip it with Open Compute Platform MES cards for fabric connectivity. In this case, it's EDR or 40 or 100 gigabit Ethernet. So just moving along. So here's just a close-up of the CPU board itself. It's a HPE proprietary design. I mean, it's our design. It's, as I said, it's compatible with the Apollo 2000 form factor for the tray, so it's got the same mounting holes, and we use the same bent tin as we used for the Apollo 2000. Yeah. So it's, it's nothing special, but it's production grade. So we're actually on the second iteration of that board. We did a spin to address some manufacturability issues, so we're on the second generation of it already. So the program itself, I like to think of it as it's a really deep collaboration between HPE, partners, and customers. So the key component is to actively drive the functionality, stability, and availability of the open HPC software stack, and allow that to directly compete with x86. So HPE created and is driving this program. I've just got my PC's wobbling about here. So we provide forums for discussion within the program. We provide ability to share information openly within the entire program. And that's actually been an interesting model because I think the HPC community is not used to doing that with pre-production hardware. And so we've often had the time where people say, well, I don't know how to share this. And it's like, well, just share it. And they're like, yeah, but this is all NDA. It's like, we're all under the same NDA. It's all okay. So it's been interesting getting that far. So the partners are the commercial entities that we're working with. And so they're listed across the bottom. And so no ranking. Oops, sorry. Wrong button. No ranking is implied here, but we've got, by the order I'm going to talk about this. So obviously we're working with Red Hat to provide RHEL to the program, and John described, he's willing to supply that to anyone that approaches him. While not every package is available that's available under x86 is available for ARM, the power of getting an early access system like this and simply being able to type yum install foo is hard to overstate compared to bashing rocks together. When you want to do something, pick something at random, HDF5, pick anything like that, and you end up in dependency hell. Whereas you can just do yum install foo, and you don't have to worry about which version of this, that, and the other do I have to get. I mean, on other platforms, I've been around this block a few times before. Other platforms, you end up just even to get configure to run, you end up to run something. You end up in a living hell. So I think we've all been there. And it's especially painful when you're in a living hell trying to even get modules to build, because then you can't get out of hell. So it's both refreshing and productive to be able to have that, I will tell you. We're working with Cavium, obviously, as well. In addition to close cooperation on the hardware design, I think it's important to point out that they've got, they're providing platform enablement features. So, they're providing code for the UEFI support that John was talking about. They're also, they were responsible for pushing all the ThunderX2 changes into GCC 7.1, and they actually bundled a version of GCC 7.1, so we didn't actually have to build it all from scratch. It was all very nice, because they were ahead of Red Hat in that particular area, because Red Hat's compiler releases are on a different track, aren't they? So, they're also working with us to do benchmarking and performance measurements, so it's all very good. ARM providing the HPC tools, as Grant said, they were willing to provide their HPC tools to people who are going to move the ecosystem forward. I think we fell into that category. And one of the great things for us is their release cadence is much faster than the GCC release cadence. So, he talked about he's on 1.4. of the compiler just came out. So that's been great. We're picking up changes, specifically, like you said, in the area of functionality. So it's just easier to use, and the PGI Fortran front end's been a breath of fresh air. They're also working on MPI SHMEM issues with us. So Mellanox, we're working with Mellanox. Mellanox are the fabric vendor we've chosen for this. So we're working with them for all OFED and InfiniBand issues, performance, completeness, compliance. It turns out customers can choose between Mellanox OFED or distro OFED. Mellanox's approach now is to push their changes upstream aggressively, so that Red Hat, I think it's something like 90-something% commonality between the Red Hat distro OFED and the current Mellanox OFED, which is very good. I mean, Mellanox is always going to do the bleeding edge stuff in Mellanox OFED. It's just the way it's going to be. But distro OFED is not very far behind it now. It's very credible. So, and we're working with AMD for the GPU accelerator implementation. As I said, we're using the FirePro 9170 in this program. We're working together, cooperating in multiple, various configurations on specific aspects, performance measurement, improvement. Some standardization work needs to be done. There's some work where I think it's fair to say that the OS, the ARM OS community, I think John alluded to this, has sort of kicked the can down the road a bit in terms of standardization in order, under the guise of being really responsive and really flexible and really innovative. But as he says, boring and easily deployable is a very good thing. Running like the wind is a very good thing in HPC, but boring and deployable when you're trying to do 1,000 nodes in a few seconds is important. And the other thing is all improvements and developments we're driving back into the community. This is not a walled garden here. So let me just move on. I'll give you an example of this. And this is an eye chart. You're not supposed to be able to read this that accurately. But this is, we had an example where we're measuring stream, right? Stream performance. I mean, the Cavium Thunder X2's got 8 DIMM channels. So memory bandwidth is an important thing for it. And memory bandwidth, we think, is kind of a first-order indicator of application performance. So it's a good thing to measure. And we were getting some bizarre results. And you see the graph on the left is, by default, RHEL ships with transparent huge pages turned on. And so the graph on the left is the performance of, from the horizontal axis is core count, is active cores from 1 to 56, and the vertical axis is memory bandwidth. And you can see, the left vertical axis is memory bandwidth, the right vertical axis is standard deviation. And you can see that, this is with OMP bind, proc bind set to spread. So you can see that, your memory bandwidth climbs pretty aggressively, that's fine. But then something very strange happens. It goes to hell in a handbasket. And more importantly, look at the standard deviation across the bottom is, that's hovering around 20. So it's a pretty awful standard deviation. Someone in Manchester, Chris Goodyear's group in Manchester, noticed that if you turn transparent huge pages off, you get the graph on the right. That's the only change between these two graphs, is transparent huge pages turned off. And you can see the left vertical axis is actually slightly different between these two. I didn't have a chance to normalize them, I apologize. I didn't have a chance to normalize them to put them on the same graph, same vertical axis on the left. But you can see there's a very tiny X. I don't have numbers associated with that because I think Cavium would be mad at me if I did. But there's an X there. The X is the same point on the two left vertical axes. So you can see we not only exceeded the memory performance, the memory bandwidth, but more importantly, it became somewhat predictable. The little glitch around 36, so between 32 and 36, actually turns out it's a bug in libomp. So It's got nothing to do with the processor at all. But the standard deviation in particular, if you look at the right axis, that's changed. It's a 20th. The right axis is a 20th on this right-hand chart. So, the standard deviation is hovering around 1. So it doesn't go to hell in a handbasket, it behaves predictably, it's exactly what we'd expect. So that was something that, it took Cavium, ARM, HPE, and Red Hat to work together on that. And John can tell you the details, but I believe the last update I got from John was there are generic problems in transparent huge pages code that are not processor specific. This is just uncovered bugs in the transparent huge pages code. And there are also probably some platform specific issues, some ARM specific issues, but we've uncovered both of those issues, both kinds of problem. And there's multiple examples like that we've been going through. So there are numerous other examples like that. So the customers we're working with, we're working with Big Five, the US DOE labs. These customers are purchasing or have purchased. Jim alluded to the fact that it should have been on his dock already if it wasn't for Hurricane Harvey. Small to medium-sized clusters. So this is just not 1 or 2 nodes. A bunch of these customers have already received 1 or 2 nodes, or in Jim's case 4, and they've been working with them so far. But these were small to medium-sized systems. I think the biggest systems run about 100 nodes. So they're enough to do serious work on. And as part of the program, each of the customers has selected 1 or more packages or capabilities to focus on and contribute back to the community as well. So this isn't just HPE selling early hardware to a bunch of labs. It's actually, we're committed to trying to move this ecosystem forward. So the way we structured this program was, to get into the program, you had to demonstrate how you were going to, as the Americans say, move the ball forward. So, and these are, the labs were, we coordinated things, but the labs were free to choose what they wanted to, the customers were free to choose what they wanted to work on. Areas of expertise that are specific for them, areas that are regarded as important by them, or areas that are specifically known to be deficient in the ARM ecosystem. And for example, Livermore is actually porting TOS, which is the tri-state, which is the commodity operating environment shared by the 3 NNSA labs in the US for their commodity systems. And I want to make sure I get the numbers exactly right here. And so to date, and this is literally a couple of days ago, I asked for the update in the latest state where this process is in, 193 packages that form part of TOS but are not supplied by either RHEL or the Fedora extra packages, EPEL, have been successfully ported. Only 3 packages are still in process. So I think that's a remarkable state of affairs. So Grant mentioned the Open HPC process. We're also leveraging that, and I think Grant covered, we're at 1.3.2 in that, and that process is moving ahead aggressively. And we're getting down to, getting rid of really, I think it's showing that people are really using it, really building it, and really trying to deploy it now, because we're getting down to the you can't get there from here problems that show who's actually really doing this and who's just, got a build going that they're not using. So with that, I'll take any questions.